No problem.
All right, today we're looking at derivatives of natural logs. This is the one function we haven't looked at. So we want to start by going over some properties of natural logs. Remember, logs can be expanded through addition if they're multiplied on the inside. So in this case, we have log base 3 of 5 plus log base 3 of x squared plus log base 3 of the square root of x minus 3. And then we can also bring down powers from the inside to the outside. So this one doesn't have a power, so we can leave it as log base 3 of 5. This one has a squared on the x, so we can bring it down to the front, to log base 3 of x. And this one has a 1/2 on the x minus 3, so we can bring it down to 1/2 log base 3 of x minus 3. We can solve logs by combining through these same processes. All right, so here we have a subtraction, which means we can combine these logs into division. Log base 3 of x over x plus 3. And then we can undo a log by changing it to an exponential. So we can say 3 to the negative 2 power equals x over x plus 3. Rearrange and solve, so x plus 3 equals 9x, 3 equals 8x, x equals 3 over 8. The one thing we have to make sure of when we solve is we have to plug it back in to the original x's to make sure we don't have a negative inside the log, because you can't do log of negative. The last one is this one right here, evaluating the integral of 1 over x. And we'll come back to this one in a bit, because it doesn't work like our normal power rule. We can't just say the integral of x to the negative 1, add 1 to the exponent, and divide by the new exponent, because we end up dividing by 0, and you can't divide by 0. So let's look at what we're looking at. If we graph natural log of x, we end up with this right here. Okay? And then if we try and graph its derivative, let's look at what we end up having. We'll call its derivative in blue. We have a almost vertical slope, so a really positive slope here that gets closer and closer to 0 as we go on, but never actually touches. So that's this right here. And this looks kind of like a function we've seen before. It's just missing the second half of it. So let's change this to log absolute value of x. Well, that allows us to have another function on this side that looks the exact same. And then we can create our derivative of that one, which is an almost 0 slope but decreasing, so negative, and then it becomes a more and more negative slope. So based on this graph, it looks like our derivative is going to be 1 over x. And that's true. If we look at it, the general rule for the derivative of natural log of x is 1 over x. The general rule for the integral of 1 over x is natural log absolute value of x plus c. And we can apply both of these to all the different types of derivatives and integrals we've done before. But now, with log rules, we can make things easier, harder, however you wanted to say it, depending on what we have. So like, for example, this one, we can do a chain rule by just doing the derivative of the outside, 1 over 2x, times the derivative of the inside, which is just 2. And that'll give us 1 over x. No log rules needed. We just get our chain rule and get our answer. For this one, we can separate it using log rules to say this is y equals natural log of 2 plus natural log of x, and then take our derivative. Natural log of 2 is a constant. Derivative of a constant is 0. Derivative of natural log of x is 1 over x. Same answer. Different steps to do it, but either one would be correct. All right, so there's just a couple practice. I'm going to look at this one right here, because this one is one a lot of people are going to look at and see, oh, it's really complicated, but this is where our log rules can come into play. We can separate this into natural log of x minus natural log x squared minus 1. Now we still have to do chain rule on this side, but unlike what we were originally looking at, we don't have to do chain rule and quotient rule. We can just do our chain rule there. So our derivative, g prime of x, 1 over x minus, and then 1 over x squared minus 1, times the derivative of the inside, which is 2x. Now, one thing about these problems, you do need to get common denominator if you're taking the derivative. So we get common denominator. We get x squared minus 1 minus 2x squared over x times x squared minus 1. We get negative x squared minus 1 over x times x squared minus 1. All right, so all of our normal derivative rules still apply there. All right, here's just some more derivative practice if you wanted to do it. And then we could also do implicit differentiation with this idea. We can find extrema with this, still the same things. Now, I will talk about this one real quick to find the extrema because we need to talk about the getting common denominators. So if we look at this, we remember we have to get common denominators before we can find the max or min. So just make sure when you see this on the test or quiz, you get a common denominator and find both critical numbers, both, in this case, 1 and 0. But when you do your sign chart, while you'll get values on the left side of 0 here, can we ever plug a negative into natural log? Well, that's no. So this doesn't actually exist in our function, this side of 0. The only part that exists is the values greater than 0 there. All right, last one is logarithmic differentiation to find this. This is a way to make derivatives slightly easier. So if we look at this one, this looks like a really ugly derivative at first. But we can take the natural log of both sides and make our derivative a little bit easier. Using our logarithmic differentiation, we can separate this using our log powers. So natural log of x minus 2 squared minus natural log of the square root x squared plus 1. We can pull down our powers. Okay, but we still have this natural log on the other side. Oops, natural log of y. So whenever we go to take our derivative, we have to do implicit differentiation on this side. So 1 over y, dy over dx equals, and then on this side, we have 2 over x minus 2 minus 1/2 times 1 over x squared plus 1 times the derivative of the inside, which is 2x. And we need to get common denominator, so we end up with 2x squared plus 2 minus x over, minus x squared plus 2x over, and then x minus 2 times x squared plus 1. We'll simplify it down, and we'll multiply both sides by y. So we have x squared plus 2x plus 2 over x minus 2 x squared plus 1 times y. And we can't leave y in our answer, so we will have to plug back in the y. But things will simplify for us. The x minus 2's will cancel, so we're left with x squared plus 2x plus 2 times x minus 2. And then on bottom, we have x squared plus 1 times the square root of x squared plus 1, which is x squared plus 1 to the 3/2. Okay? All right, let me know if you have any questions. Send me an email. I'll see y'all next time.